Welcome to day 4 video, rational functions, adding and subtracting. You should have your packet out, so if you don't have your packet out, please get it out. This is about the 3rd page, maybe the 4th page, but you want to find something that looks like this, 8.5, notes, practice problems, adding and subtracting rational expressions. So we need to simplify, and when we're adding and subtracting, we need to make sure that our denominators are the same. Right, so we've done simpler problems such as this. If I wanted to add 2/3 and 5/6, I need to make sure those denominators are the same before I add them. So I could make the same denominator as a 6 by multiplying by a form of 1, 2 over 2. 2 times 3 is 6, 2 times 2 is 4. So I would get 4/6 plus 5/6 and 9/6, or 3/2 would be my answer. All right, but the whole concept of adding or subtracting fractions is we have to know, okay, this is how many pieces we have, and this is how many pieces it takes to make a whole. All right, so we want to keep all those things in mind when we're working with these. So the first thing we want to look at, we have an addition. We need to add these two fractions. Now, if our denominators are the same, we're good to go. We're going to keep the same denominator, right? And we're going to add the numerators. We're going to add like parts. So I have 1u and 6u's, and I'm adding them together. So together, I have 7u's. Over here, use a different color, we have a negative v, or negative 1, plus a negative 3. Negative 1, negative 3, negative 4 v's. All right, now some students will want to go, oh, let me see, there's a v and a v, and I can just cancel that out. You can't cancel it out, right? We need to have, if you can factor out a v and have a product of v times something, then you could simplify the v's. But in this case, this whole thing is one factor. This is 8 times v, but this whole chunk, unless we can factor something out, it is one factor, and we can't start crossing things off if it's a part of a factor. All right. Okay, so let me do one more of these with you, subtraction, and then I want you to try number 3, 4, 5, and 6. So same denominator, keep the same denominator, 6m cubed n. And instead of adding, now we're going to subtract. But what I want you to do is leave, change, change. You're going to leave the first one, change the minus to plus, so we're adding the opposite, but we're adding the opposite of each thing. So we're doing leave, change, change. We leave this one alone, we change minus to plus, and we're adding the opposite. It's the same thing as subtracting. We need to make sure that we make each of these the opposite. So minus becomes plus, the opposite, and opposite. Okay, so we have the same denominator, keep it. M minus m is nothing, simplifies. And negative 3n minus 3n is negative 6n. Now in this case, do we have a sum or a difference? No, we just have factors. So 6 divided by 6 simplifies to negative 1. So that's now a 1. N divided by n simplifies to 1. And our final answer here would be negative 1 over m cubed. So we're adding these two up. In this case, we want to consider maybe a restriction. We don't want to let m equal 0, right? Also over here, we could say v is not allowed to equal 0 as well. All right? Okay. I want you to try number 3, 4, 5, and 6. So try these guys. Add them up. See what you get. Check out your restrictions. All right, I'm going to go ahead and hit pause. You hit pause, try them, and then check them. Thanks. All right, your answers should look something like this. Here we added 5 and 1. They were like terms. We got 5a plus 6 over the denominator, but we needed to factor in order to find our restricted values. So we factored and found a is not allowed to equal -2 or -1. Either of those values would make our denominator equal to 0. So go ahead and check your answers for a second. Over here, the factoring was a little more complicated. You could have factored out a 2 first. Made it a little simpler. I just did a Mr. Choi method over here. All right, so if there are any questions on those guys, please write those questions down and bring them in to me tomorrow for class. All right, so we want to look at something called the LCM, the least common multiple. So I'm going to start with something simple and then move to something a little more complex. We have 5/12 plus 4/15. Now, you could, and oftentimes students will tell me, oh, just multiply by 12 over 12, and over here multiply by 15 over 15. But that's huge. I really don't want to multiply by such a big number. I'd have to simplify a lot. So really, I want to look at 12 and 15. I want to look at what factors do they have in common and which factors are unique to them. So a 12 we can break down, well, I know it's 4 times 3, 3 times 4, but instead of writing 4, I'm going to write 2 times 2 because I know 4 can factor to 2 times 2. And 15 can factor to 3 times 5. Let me erase that. Okay, notice how I wrote these factors. I lined up my 3's. 15 didn't have any factors of 2, so I kind of left some space. And then a factor of 5, which 12 did not have. So I want to look at, okay, what factors do I need? I need to have, they both have a 3 already, and I need a 3. I also need 2 factors of 2, so I need a 2 and times 2, and I also need a factor of 5. So I need the largest of each. So here, the largest power of each factor. So this is like 2 squared. But really it's like, okay, fill in the blanks. What does 12 need to be multiplied by? Well, we still are missing a 5 factor, right? So on this side, we're going to multiply by this form of 1, 5 over 5. And here, the 15, what the 15 is missing is a factor of 2 times 2, or a factor of 4. So here, all I have to multiply by is 4 over 4, right? But we're multiplying by a form of 1. Now this is going to help me. 4 times 15 is 60, and 5 times 12 is 60. So now we have a common denominator, and it's not this huge number, all right? 5 times 5, 25. 4 times 4, 16. Add those up. 20, 30, 41 60ths. And that would be our final answer. So our goal here is to get the same denominator, but the way that we get it is we look at, well, what are all the factors of 12? Break it down. And what are all the factors of 15? And what is missing that this has that this doesn't? And then what's missing here that one had, but this one doesn't. And those are the things we need to multiply by. That tells us what our form of 1 is going to be. All right, let's kind of apply this to our a little more sophisticated or complicated problems. Let's see. I wonder how this will work. There we go. Oh, no. I wonder how it's recording. That's okay. If it's blue, it's blue. Here we go. All right. So we want to look at our denominators. Are they the same? Obviously, they're not. Okay, so I'm going to list these. I've got x squared minus 4. That's one of my denominators. And I've got 3x minus 6. Now, in the other one, we listed out the factors. So I want to factor this. What times what gives me x squared minus 4? And you guys can see it's just x plus 2, x minus 2. It's a difference of 2 squares. All right, and then over here, again, I want to line up similar factors. Here I have a factor of 3. That's not in that, so I'm going to put a little separate. 3 times x minus 2. Oh, that one's the same. X minus 2. So see how I lined it up? All right, so I want to look and say, okay, well, what factors are missing? For this one, I'm missing a factor of 3. And for this one, I'm missing a factor of x plus 2. So in order to make them have the same denominators, I need to multiply this guy still by x plus 2. So no, I said that wrong. I'm going to multiply by form of 1, which is x plus 2 over x plus 2. And over here, I'm going to multiply by whatever's missing in this denominator, and that is a factor of 3. So I need to multiply this whole numerator by 3 and this denominator by 3. Okay, so then we're going to do that, and we're going to get 3x squared minus 12 as our new denominator. 3x minus 6. And then here, if I multiply these together, I get 3x squared. 3x squared minus 6x plus 6x. Aha, they cancel out. And then minus 12. Notice we got the same denominator. That was our goal, right? Because in order to add these two fractions, they have to have the same denominator. So we have the same denominator now. Again, we have to multiply these two, use distributive property. 2x plus 4. All right, so we keep the same denominator. And our numerators, we add them together because it says add, so 3x plus 2x. Negative 6 plus 4 is negative 2. I want to check and see, can I factor anything out of here? If that was a 10, yeah, I could, but there's nothing else I can factor out, so I know that I'm done. But I do want to restrict any values, and I have all my pieces up here. This will help me see, oh, well, I can't have a positive 2, I can't have a negative 2, so x is not allowed to equal 2 or negative 2. Those are going to be, if I was to graph this y equals and graph it, those would be my asymptotes. All right, so this would be my simplified version, plus a couple restrictions. All right, so we actually just did number 4. Sorry, we just did number 4. I was supposed to tell you that on the next page. So I want you to try a couple, and then we can check some answers. So try this one. This one has the same denominators. Try this one. And try this one. All right, so try those couple. So we did this one already. Try 1, 3, and 5, and then we can check the answers. So hit pause, try those, and then we'll see if we got the same answers. All right, and these should be the answers that you get, or the simplified expressions with some restrictions. So check them out, see how you did. I think this is by far the most complicated one here. Here you just have to multiply by 3 over 3, 2 over 2, but here you're actually multiplying by another binomial. So yes, you do have to use FOIL or the distributive property, right? You're multiplying these here and here, those here and here. Once you get to know these, you kind of see the pattern here, right? X times x is x squared. You get your b from adding these two together, and you get your c from multiplying those two together. So if the more and more you're comfortable with those, the quicker they go. If you want to work on those, you're welcome to come in at lunch and work on them with me. All right, so if you have any questions, write them down, and we will go over them in class. Thank you so much for watching. You are so responsible. All right, bye.